You are here for relational data modeling trends for transactional applications. And so this session, the intention behind this session is to show you some thoughts that you should have while approaching schema design for applications. Now, unlike my other session, where I sought to be comprehensive to give you everything you needed to know to design schema for analytics, this session is slightly different. I am not here to teach you the last 30 years of transactional data modeling. And the reason why I'm not here to teach you that is because I want you to abandon it, okay? I don't like what we did for the last 30 years, and it's not going to serve us very well for the next 30 years, okay? So I don't want to spend a lot of time teaching you about schema designers and all these things. I want to spend time refocusing your priorities while you create schema. That's what I want to do, is instead, it's less tactical, and it's more, these are the things I want you to be thinking about with your schema, all right? That's quite a bit different, isn't it? All right. So if that sounds interesting to you, you're in the right place. Another thing that I wanted to kind of cover is, look at you guys. Look at you. I'm so proud of you. It's the last session of Past Summit. Everybody's got flights to catch. Everybody's got a spouse that's wondering why you've been gone so long. And maybe not everybody, but you know, you've got priorities at home where you're thinking about, you know, did my pipes freeze? Apparently, a lot of you live in places where that's a problem. But anyway, so look, I'm great. I don't take this lightly. The fact that you have these other thoughts and you're sitting here with me, I take that very seriously, and I'm very grateful for it, okay? Okay. Like I said, I don't care about your cell phones. If you have a call, go take it. We're adults. Like, I know you didn't intend to mess me up, right? You won't mess me up. I can handle. I figure if Tiger Woods can golf in front of 3 million people farting and coughing, I can handle your cell phone, right? Okay. We've got a lot that Pass offers, and I'm active in several of these things, except for Pass Marathon no, that's not kidding. But I'm active in a lot of these things. You might have seen me in some of these things before. This is a little bit about me, and a lot that's not super relevant to you, but you might want to just keep a track of my Twitter handle, because I might make this session, I believe, is important. Can you do something for me and promise not to tell Pass? Like, yeah, don't tell the rest of the Pass organization this, okay? But they are selling this stream of this, and that's good. And I'm glad that you can download that and use that. But I'm going to put this session on YouTube in the next month or two, because I believe in the content, and I believe it's important. And so I'm delivering it at other conferences, and I'm going to be making it available for free. So if you're interested in that, then follow me on Twitter, and I'll tell you when I do that, okay? Okay. Oh, damn. Yeah, yeah. Okay, so, yeah, yeah. Yeah. So, yeah. Yeah. So my agenda here, we're going to do a summary of where we've been in data modeling. And then we're going to talk about some of the weaknesses that where we've been have led us to a place that's not very fun. And then we're going to talk about our current priorities and the state of data modeling today. And if we have time, we're going to practice. I don't know that we'll have time, but if we have, sometimes before, when it's been 60 minutes, we haven't had time. But it depends a lot on you, how interactive you are. So if you look at something I've said and you need clarification, I would rather do that than finish all my slides. I would rather have the conversation, right? Okay. Okay. So throughout this presentation, I want you to remember 3 things, please. The first is that schema, even though what we're doing when we create schema in a database, we're modeling a business process. Do we agree on that? That what we do when we talk about schema is we say, we need a customers table, and we need an orders table, and we need a birth date, and we need a hire date and a salary, right? What we do when we create schema is we are taking a business process, and we are basically putting it into a database in a way that we can interpret it and implement it. Is that right? Okay, so, but I want you to remember that schema controls scalability and changeability. And often when we design schema, we don't consider those 2 things. That schema actually has a very interesting relationship with performance. if you want to create the very fastest data retrieval system, stuff everything in one large table. Make it a lot of columns and a lot of rows, and you will be able to parse over that data very, very fast. And in large part, the reason why that's fast is because that's how we get compression. Like, compression actually works really well if there's a lot of data, and if it's very flat, we can really do a really good job compressing it in different data structures. So what do developers do in like a Redis cache? Or what do they do in Snowflake? Or what do they do in some of these technologies where they're getting really, really high performance, right? They're just flattening their schema, and they're putting a lot of data in it. That's what they're doing, right? So I want you to just remember that in your head, right? Remember that schema controls performance. And also, schema controls how the business changes and how the business views their data. So when the business takes a look at a table, they're self-reflecting and projecting off of that data, right? They're saying like, oh yeah, I'm a university and I have students, which means they're here to learn. And students enroll things, and they have tuition, and they get scholarships, right? And when they see these things in the data, they have a relationship with that, right? That they're facing, right? Okay. And they expect that when the business changes, that the schema changes with it. They do have that expectation. Whether or not that's true or not, they do have that expectation. So the next thing I want you to remember, and this might or might not be true, but keep in mind that in this session, we're focusing on transactional applications, that in the average transactional application, reads outnumber writes 10 to 1. Okay? And that's important to remember, that we have applications with a very high read load. And then the third thing that we should remember is that schema should change because the business is going to change and technology is going to change. And those two things that will change will force us to change our schema. Can we agree on that? So if I said things that you think are resonating with you so far, right? Yeah. And you agree that these are truth. This is truth, right? Okay, good. Nope, you don't, Lewis? What do you disagree with? We'll see. Oh, okay, all right. See where we're going. Okay. I did? What did I say? Oh, yeah, right. On the left. What did I say? Oh, sorry about that. Sorry about that. Okay. Sorry, I'll fix that. Anyway, so schema definition. A schema is a representation of a plan or theory in the form of an outline or a model. So would you begin any major project without a plan or a theory? Would you? Yeah, you'd be surprised how much we do that, right? Yeah, right, right, right. So there are some things about schema that are happening right now that I don't agree with. Like they're saying things like schema less, right? Which to me is like no plan, no, this doesn't sound right, that we're not thinking about these things. Like we should definitely be thinking about these things, right? So I want you to know that there's things that are happening I don't agree with about modern data modeling in certain organizations, right? Like schema is important. Do you agree with that? That we definitely need to be considering schema and implementing it with a logical plan, right? Yes, I agree with you. Okay. So you know this guy, E.F. Codd. So E.F. Codd is a brilliant man. And when relational databases were in their infancy, he said, look, as we store data, we need to obey certain rules. And if we obey these rules, we will have a better time at storing data in our transactional applications. So he created these rules called normal form. And the rule for first normal form is that the data is in the database table. So first of all, we tablize our data. And the table stores information in rows and columns where one or more columns, called the primary key, uniquely identifies each row. Okay? So that means that if I have a customers table, there's going to be a customer ID, and that customer ID will uniquely identify every row in the table. It also says that each column only has one piece of data. So a bad example would be like order 1 date, order 2 date, order 3 date. Like that would be maybe a bad example of a data modeling procedure, right? You wouldn't do that. You'd have like an order date, and every row would have an order date that applies to that row, right? Okay. So the next rule that E.F. Codd outlined was second normal form. And a table is in second normal form if it's first in first normal form, And second, all the non-key columns are dependent on the table's primary key, which means you wouldn't put the corporate headquarters address in the orders table because it doesn't apply to orders. So you would only have columns in the orders table that apply to the orders: order date, quantity, unit price, shipping date, things like that, right? Okay. And then the second is a table is in third normal form if it's in second normal form and it contains only columns that are transitively dependent on the primary key. So you wouldn't put employee full name in the orders table, even though employee ID might be in the orders table. So we're using employee ID to join to an employees table, and that's where the employee full name should be. That's third normal form. And there's more of these. There's fourth normal form, but this is the basics of data normalization. And the reason why he did that, well, he had a lot of reasons why he did that, but he was really hyper-focused on data integrity and on storage space. And so he had good reasons for this. I don't want you to say that E.F. Codd was bad at his job. He was not. And his reasons were sincere and valid and important for the time, absolutely. But they led to some practices that were not super great in transactional applications. So that's what we're going to talk about. So E.F. Codd had an assumption. His assumption was that disks would always be expensive. And in fact, my first hard drive was 10 megs, and it cost my father $1,400 in 1984 for me to learn how to. This is the first computer I used to write my first applications on. And I'm grateful because at that time, $1,400 was only the price of the hard disk. The overall computer cost him $3,000. And then he bought books for me to learn because I was interested in it. And really, if it weren't for that, I wouldn't be standing here today, right? So I'm very grateful for him for doing that. But I just bought an SD card that was 128 gigs for my son's Nintendo Switch, and I think it was $22 for that. Or what's that? Oh, maybe it was 19? I don't know. Okay, I don't know. So obviously, that assumption might not have been correct, right? Disks have gotten cheaper, and actually, they've actually gotten very, very fast. Like, we have disk technology that is very quick now, right? Okay. So, but this means that if we need normalization to decrease repeated data and decrease the overall size of the disk, that there would be a benefit to over-normalizing the tables, right? And so when people took E.F. Codd's rules, they created really, really bad practices, like the example I always use is a person table. So what they did was they said, we noticed that there were data elements in common with vendors and with customers and with employees. And those data elements were things like name and address and age and whatever, right? And so we created a person table, and then we would create a customer extended table and a vendor extended table and an employee extended table for the elements that were unique for those tables, right? And that's, you would say, well, Ike, we're doing a person table and it's working fine with us, right? But the design notion isn't working fine for you. The design notion would be, well, wait a minute, phone numbers are all the same, so why don't we have a phone number table? And then a phone number type, and then link the phone number table, the wider phone number table, to all the different extended tables or the person table. And why don't we have a zip code table? And now all of a sudden, you've got all of these table explosion where nobody really knows where the data is. And in order to get like an employee list, you're joining 18 tables, right? And we already know that joining is kind of a performance issue. And the joining is very complicated for people to find the data, and it's very easy for developers to create bugs when you've got unnecessary complexity. So developers tend to create the same bugs over and over again because they don't even understand their own schema, right? And that would be why, okay, maybe the person table you can get away with, but the design notion of over-normalizing it has a lot of terrible things related to it, and the benefit isn't that great, right? Okay. So it's also terrible performance for joins, right? It's also a steep learning curve. We talked about this. I think we've got all this. Okay. E.F. Codd also had another basic assumption, and that was that a central database would store all of the company's data, and that all of the applications would use that central database. And so to E.F. Codd, data integrity was hyper important to him, because he thought that that database was going to be the gatekeeper to all the data for the whole company. And so it was important that it was right? So let me ask you, do you guys have a single database that is centrally important to your company? Raise your hand. Yeah, a lot of us do. A lot of us have that database, right? OK. Is that database super fun to change? Do you love changing that thing? What's that? If it's done correctly, you like changing it? OK. But typically, here's the problem with it, OK? And that is that one application can't release changes to the database without testing all of the applications. So in this environment, that means that if the application in the upper left corner needs to make a modification that involves changes to the database, all of the applications need to change with it. And what that does in a modern environment is it greatly increases the testing surface area before we can actually deploy a change to production. And the larger the testing surface area is, the fewer times we'll actually deploy. So that's just an inverse relationship that is a fact. If you have a small testing surface area, you'll deploy more frequently. And if you have a large one, you'll deploy less frequently. OK. So the other thing that will happen is because these applications are using the database as a central data repository, they tend to use the database as their integration point, which means they begin to use the database as a method for communicating with one another. And this is a very bad practice for many, many reasons. The first reason why it's a bad practice is it creates a data signature load that is not ideal, where typically somebody implemented a queue or a message bus inside the database where they are putting events in the table and then deleting the events out of the table. And if in a high load situation, that's very bad because SQL is a persistent data store that heavily relies upon the log. All relational databases do that. MySQL, Mariah, Oracle, all of them do that, right? And so what you get is a constant grooming thing where these messages are coming in and out of a table in a high load situation, and the grooming is very expensive. It locks, it blocks, you get deadlocks. It's very, very difficult to manage. So that's one problem with the database as a communication mechanism. The other problem is that because the deletes are a logged operation, the deletes could actually launch an entire table lock. And that table lock will stop the communication from even continuing, right? This problem is a very widely known problem for people who have implemented database message queuing systems. And so they rip it out. They put it into a queuing software like Event Hub or Kafka or something like that, right? Another problem with having two applications use the same database is, let's say that you and I are on a small team, and we create an application to do, let's just say we have a sales calculator, right? We create a little tool that helps salesmen figure out the true cost of our products so that they can bid it out to people. And we think it's pretty cool. And we think, well, we've got one database, so we stuff that little tool in the database, right? And all of a sudden, the salespeople, they love that tool. They use that tool every day. They're in that tool 24/7. And we're like, oh, they love it. We didn't think they'd love it. We thought they'd kind of like it, right? And so now they're like, it's slow, it's slow, it's slow. And we start optimizing it. And what you have to do when two applications use the same database is that when one gets popular, you tend to have to pay for the entire database to scale up. So if you need more memory, it's more memory for the entire database. If you need more CPU, it's more CPU for the entire database. And the problem with this is that that's not a very cloudy way of thinking about this thing. The cloud will punish you for buying CPU you don't need. The cloud will severely punish you for buying memory you don't really need. You will have 5- and 6-figure bills, and you will regret that every single day, okay? So it would be, in our little sales calculator, if we were going to be cloudy, we would say, well, we should probably use our own database, because if they really start to love it, then we just have to scale a small thing, right? Not scale a really big thing, right? Small scaling is affordable. Big scaling becomes cost prohibitive rather quickly, right? So we would want a small thing for our little application, right? So the other problem is now that if our sales calculator gets a high load and we don't have the money to scale the database, other people really start complaining about it. So now other people are like, hey, the server's slow, and I'm just trying to clock in my timesheet. How come I can't file this expense report? Because the server's slow. And they don't like to hear, users don't like to hear, well, the salesmen are on the sales calculator, right? And you're like, well, I don't give a shit. Like, just make me clock in, right? Okay. So because the database is shared, it's the best place to have to be responsible for data accuracy and consistency. And this is a very bad practice. So what we're basically saying is, if we are enforcing data integrity at the database, then we don't have to worry about bad acting applications interfering with one another. That's what we're saying. And it's really a way of paying off some very severe technical debt. Because what happens is, if you follow that design notion to the nth degree, you create a lot of business logic in the application, a lot of application business logic that goes into the database to enforce data integrity. And that's not the greatest thing for a lot of reasons, and it's particularly not great in the cloud. Because if you're a SQL Server professional, you know that your licensing is tied to the CPU. And so the more data integrity notions that you enforce in the database, the more you'll use the CPU to execute that, right? You'll get larger and larger stored procedures. You might even get triggers. That would be bad. You get a lot of CPU utilization. And that CPU utilization is expensive in the cloud, right? And so you'll start paying pretty severely for that. Where if you rip it out and you put that logic in an application, the CPU for that application can be much, much smaller, much easier to control, and much, much cheaper, right? So we're doing it because it becomes unaffordable to do that in the cloud, right? Okay. The other problem with stored procedures is that they can be difficult to test, difficult to change, and even difficult to read. How many of you have a stored procedure that when it has to change, you really dread it? Right. So when you dread change, you are effectively telling the business to please not change. That's what you're telling the business. You're telling the business that now we have a conflict point between how the business wants to grow and how you want to do your job. And that is a very, very bad place to be. What you want to be is in a place where when the business changes, you're excited about the change. You want the change. You can't wait to see what the business is going to do next, right? And so the stored procedure is blocking you from that feeling, right? So that's the problem with a lot of business logic in there. Business logic in Python is much, much easier to read than business logic in SQL. It really is much easier to read. And when you want to put it under test, it's much easier to put it under test in Python than it is to put it under test in SQL. In Python, I can put data under test in PyTest and in Gherkin and Cucumber, and I can do BDD testing and unit testing and integration testing and seam testing. Okay, now name all the testing tools that SQL has. Okay, T-SQL-T. All right, now we're number 2. SQL testing, T-SQL-T are, yeah, there we go. All right, so what's number 2? Okay, APEX, hey, good work. It's you again. Yeah, one guy knows another testing tool that's actually pretty good. Okay, so, but the point is that it's not widely known, it's not widely adopted, and there's not a lot of options, is there? Right? Okay. So have I done an effective job of communicating what might have been going wrong in our schema design earlier? So you feel that? You feel that there's some bad practices here that we should clear up? So I created a checklist that I called our current design priorities for modern transactional application design. And so I'm not really talking about the implementation necessarily, although I will talk about it, but I just want you to talk about the thoughts you should have when you create schema. Can we agree that the data needs to be consistent and high quality? Can we agree with that? Yes, that is very important. So we need to choose correct data types. We need to allow for nulls if the value is unknown. When data is wrong, we need to create a correction plan and fix it. And we need to have tests that are built around data quality, right? Do we agree with that? Yep, okay. All right, good. So think about that when we design schema. How about this one? do we agree that schema should be able to change with the business? So that when the business, I had a university, I'm not kidding, they decided that they thought students was condescending, and they changed the word to learner. Yeah, so they really wanted every single time the word student was in their database to be replaced with learner. They really wanted that. Who would be excited about that job? Right? So do you have outdated taxonomy in your database right now? Raise your hand. Where the names are wrong? Right. So why is that? Why don't you want to go change it? What's that? Because you don't know what you'll break. Bad application code, and you're worried about what you'll break, right? But look, the reason why I'm not telling you how to make good EF-COD applications is because when everybody's doing it wrong, maybe there's a problem with the system. So when everybody says, you guys, everyone just raised their hand and said, I have stuff I don't like changing, right? So there's something wrong with the system. Look, if one guy makes a mistake and 9 other people do it right, then I'm like, hey, you're an idiot. Do it the other way the 9 people are doing it. But when everybody's having problems, we need to think systemically about the solution to these problems. And that's why I'm provoking like this, OK? All right. So that the business is complaining that the database is not changing as fast as the business. The business changes taxonomy. If the database doesn't change, it creates bugs, confusion, and ambiguity. Technology changes. New index structures, new table structures, new database technology, new versions of existing technology. And the real problem with technology changing is when the database is the central gatekeeper for all things data for 4 applications, the reason that's stopping you from upgrading to a new version of SQL or a column store index or in-memory data structures is because the testing surface area got too big for you. So you didn't want to implement the change because app 4 breaks. App 1, 2, and 3 love it. App 4 breaks, change rolls back. And now you're in a place where you can't change. You want to adopt new technology, and you can't do it because one little corner of a too big application is affecting the wider application, right? Does that make sense? OK. Yeah, it's like a fight with 4 managers. That's exactly right. Yep, that's what you'll see often. Yep. So the microservices method is based around keeping schema flexible. When people talk about microservices, the developers don't include the data architects about why they're doing it. But here's why. The main central reason why they're doing it is because the developer of a small portion of the app wants total control of their data store and schema. That's why the developer's doing it. So what they tend to do is they say, take this giant monolithic database and divide it up into 20 smaller databases. And then we're going to have one little thing against one small portion of what we're doing. That's what we're going to do. And the reason why they want to do that is because they want to scale separately. If we write the sales calculator, we want to scale it separately. If we decide that there's taxonomy in our database that we don't agree with, we want the flexibility to change it without accounting for everybody else. If we decide we want to use MongoDB or Cosmos or SQL Server 2000, 1 million, whatever the next version is going to be, we want to go to that version of SQL Server and not talk to everybody else, right? Not even tell them we did it, right? So we want control over our application, our portion of the application end to end, right? And how do you do that? Well, typically, you pick an application and database size that the team can manage where the remediation path is acceptable. So in our case, if all 4 of us are on the same team, and you say, hey, you know what would be cool in the sales calculator if we had like some visualization so that they could see project their future sales, right? Yeah, do it. Put it in the database, right? If another team came to us and said, so another team in another building, they came over to us and said, hey, you've got some data in that sales calculator that I want. Do you mind if I touch your database directly? That's so rude. Why would you even say that? That's the rudest thing you could have asked me, right? It's like, Louis, sometimes I'm in your neighborhood. Do you mind if I use your bathroom? Can I have the key to your house so if I can use your bathroom when I want? Is that cool? And yeah. And by the way, I noticed you're out of toilet paper. right? So, like, Lewis would be like, Ike, you're my friend, but like maybe like knock, right? Or like ask me, right? First, right? So the idea behind microservices is it is a very rude thing to ask for direct access to a database. In a microservices environment, the answer to that question is always, no, thank you. And by the way, don't ask that again. That's super rude, right? So don't do it, right? That means no Excel, no SSIS, no ETL, nothing touches the database except one application, one database. That's the microservices method. So what happens is you get 20 databases, and you're asking me right now, no SSIS, Ike, how do these guys share data, right? Is that what you're concerned with? How do they share data? And the answer is they just ask me. If you asked me that you want a data fill, how would that conversation go? We would say, hey, Phil, how do you want it?
4 columns, all the rows.
4 columns and all the rows. OK. Is it OK if I dump it into a CSV and you pick it up?
If it's pipe delimited.
Oh, pipe delimited. All right, I can do that, right? Is this format OK? Is this format OK? We negotiate. And I drop it into a CSV, and now he's ingesting it. Is that optimal? No. He doesn't really like CSVs. He's a developer. He's like, CSV, Ike, this isn't 1984. Like, come on, get out of here, right? So I say, hey, is it OK, Phil, if I drop that data on an Event Hub or a Kafka message queue for you, and I just, every time I change it, I publish it on the queue? Can you pick it up off the queue? Perfect. What we have done is we've decoupled Phil's application from my application. So I have plenty of ways to get data over to him. I can use APIs. I can use messaging. I can use data drops. I can do all sorts of polite things to get data over to him. But if I give Phil direct access to my database, I have frozen that schema. And if you remember nothing else, but you remember that, I want you to remember that when you give people access to your database, you are permanently cementing that schema. Because if I change it and Phil's app breaks, he's going to roll me back, right? OK. All right. So, yep.
About data duplication.
Yeah, data replication is often used to.
Duplication. By doing that, you're duplicating data.
Yeah, we are. Yeah. Yep. We're going to see a lot of that. And I want you to keep that question in your head, because I'm going to duplicate the hell out of this. Yep. Yeah.
So maybe you've touched on this, but really you're talking about loose versus tight coupling, right?
Yes, I'm loose coupling. Yep, that's exactly what I'm doing. Yep. That's the whole point of microservices. So we consolidate database logic in a data tier. And again, what we're doing when we do that is we're actually decoupling the application from its own data store so that one can change without the other one changing. So that way we're controlling where we're changing when schema changes. We agreed that schema had to change, right? This is one way that we're allowing for schema to change without the entire application being rewritten, right? OK. So we use an ORM or views or CodeGen or Swagger. We've got a million Dapper or in Hibernate or any of your framework. I don't give a shit. Just decouple, OK? Right? Can we agree that? Decouple? OK. All right. So CDP number 2. When applications need to integrate with one another, we integrate through APIs, messaging, or eventing, but we don't integrate through the database. OK? So we do it the right way. We do it the polite way. Now, here is the controversial part. EFCOD wanted you to optimize your data schema for writes. And I would like you to optimize your schema for reads. Because reads out. Did somebody clap? Oh, that's so great. Thank you. I'm glad it appealed to you, sir. That's important to me. So if reads outnumber writes 10 to 1, it is critical that we create schema that accounts for the reading of the data. Because if we do that, we'll be better off, right? So there are a lot of ways we can optimize for reads. We can and should, in high-load systems, use read-only secondaries, because that will get the readers off the right server, right? We can use Redis cache. That's often under. Oh, somebody's taking pictures and stuff? OK. We can use Redis cache. That is often underutilized on a lot of applications. But what we're effectively doing is duplicating the data in a cache for reads, right? That's what we're doing, right? And then you could do something like this. You can create an orders table So this is a schema that we have designed things very similar to this at Crafting Bytes at my company, where you will say order date, quantity, unit price, and total price. EF-cod would say that total price was data duplication, that you could derive it from quantity and unit price, and no reason for the application to create total price, right? But we have done this to great effect. And then we could also, in the customers table, we could create a total order amount, meaning if I wanted the customer and all the orders that they made for that customer, I could query the customers table only and get their total order amount in one place. Now, or what we could do is we could say, give me the JSON in one field for all the open orders that that customer has, because typically when we query for customers, we want to know what orders are currently open, and we don't want to go to the orders table to do that. We want to just get all the open orders in one place. Now, is that provoking? Yeah, everyone's provoked. Yeah, Phil, you had a comment.
To be clear, are you saying that when you go to create a new order in the same transaction, you also update that JSON?
That is what I'm saying. That is what I'm saying. And you?
Is there an option for kind of a hybrid approach here, which I'm thinking about in a SQL Server world, like you're sticking a blob on the main table, right? So it's like any access to the
Yep.
cluster next to be like, cool, I'm reading that JSON now too.
Yep.
If you stuck that in a separate table where you're optimizing for reads, it's like, if you need that, go over there and get it. But if you don't, then you're keeping your main table tight.
OK, these are all very, very good questions. OK? And I should say something very clearly. I am about to link what you thought were disconnected thoughts into one thought. OK? And it's important that if you're going to obey these CDPs that I've outlined, that you obey all of them. And don't just pick the ones you like. Because if you pick the ones you like, you will have data consistency problems. OK? Our current design principle. Yeah. Yep. All right. Yeah. So let's talk about these concerns you have, because these are valid. First of all, I'm grateful for these concerns. The duplication concern, the concern about what are we doing with all these rights, and are we going to be able to keep them consistent? All these concerns are valid. They're valid concerns, OK? But let me just answer it real quick. If I have one application, one database, we agreed on that, and I consolidate all of my logic for the database in one place for the application, we agreed on that, and I covered the application in tests so that I understand that that application is automatically tested, we agree on that, right? Then, if I have data consistency problems on a write, meaning somebody's not updating the total price when I insert a quantity and unit price, that is just a bug. And I file that bug report, and I have a developer cover that use case in a test, and I fix it. I fix the problem. The test verifies that the problem is fixed, and I deploy. So data consistency and data accuracy are the role of the application. It is not the role of the database. Right? OK. Now, no, you don't think so, Lewis. All right, follow with me. OK. That's a huge thing. Yep. All right, follow with me. OK. Let's think about this for a second. So if I have I have a customer. They have a grid screen for their application. And when that screen gets populated with data, we put Profiler on it, and we found 136 round trips to the database to populate that screen, right? OK. So they designed that screen to use an over-normalized database, right? Do we agree on that? OK. If ideally what should have happened there is that application made one round trip, right? That would be ideal, right? And that was possible. We can have an application that makes a single round trip to the database to get the data that it needs and bring the data back, right? But we can't do that if we've over-normalized, because we've effectively created a very large transaction, and we have really hurt the concurrency of the application, right? Okay. So again, I'm having you keep these design ideas in your head for just a second, and I promise it's going to snap into place for you, okay? So, but let me just cover one other use case. So all open order JSON, right? What happens if an order gets inserted and that doesn't get updated? Whose fault was that? The application. So can't the application fix it? Isn't that possible? Okay, what is the case where the application can't fix it? What's the use case where an order could get inserted and that doesn't get updated? When does that happen? Yeah?
A data fix.
A what?
A data fix.
A data fix? Ooh, we can't do that in production anymore, right? Yeah, we don't do that. Yeah, that's against almost every compliant organization, every standards organization in the world. We can't do that. So we're not going to be rolling production data fixes on a database, right? That's called drifting, right? We got to be very careful doing that. So, but thank you. I appreciate the feedback. Yeah. Anybody else? What's another case?
I don't think it's impossible for you to get it right if you do have the right kind of programmers. But what if you have like 50 of these things and hundreds of these kind of, like open orders JSON, fine. But then you may have unopened orders JSON and
Yeah.
partially open orders. And this
Yeah, sure.
and you can
Absolutely.
kind of create the JSON in one round trip if you know what you're doing with SQL, right? As opposed to thousands of round trips. Like, that was.
No, I like this, Louis. Hang on one second. So I like this thought process. So you're saying like, okay, what happens if you start denormalizing to the nth degree, and now all of a sudden you've got all this JSON flying around, right? Okay. And that is a problem. So full stop right there, that's a problem, right? But that's a problem with the application and the application developers, right? And so if the developers have dug that hole where they've denormalized to the nth degree and they've got these things sprawled all over the place and now the writes are a problem, that's a bug that the application developers can fix, that they can deploy, and they can change. And now you're talking my language, because what I'm advocating is a flexible, changeable schema. So if the developers have the ability to denormalize because they found normalization problems that were causing performance issues, now the developers have the ability to now normalize again and correct the mistake, right? That's perfectly acceptable to go back and forth, right? But they don't have that ability if they have multiple applications on the database. They don't have that ability if they have ETL touching the database directly. They don't have the ability if that guy from across the hall is pulling some Excel stuff out of it, right? Right? Okay. Yeah. So then if I can denormalize and normalize at the application level's priorities, then what's the problem with doing the duplication? If I can fix the bug and deploy, then why the hesitancy to denormalize? It's just habit. There's no real technical reason to be afraid of it, right? Yeah, I'm sorry, yeah, you.
So just on that last statement,
Yeah.
what you're saying is a lot of the normalization is to avoid right anomalies. But if you have one place where you do the right and you know it works, then the right anomaly shouldn't appear. So, but the other question I had was,
Well, thank you. You want to stand up here and take a bow? Yeah, that's absolutely true. Yeah, thank you. Did you guys hear that? Can I restate what he said? He said, if what you're saying is that when there are right anomalies for data consistency, if that's a bug and we can fix it in one place, then we can just push forward, right? We can just make it so that that bug never happens again, right? Is that restating what you said?
like those database principles that you were talking about earlier on were to avoid that. But this is a very different scenario. You have one place where you're doing all the writing. It's not 30 places trying to write to the same place.
Right, exactly.
So when you fix it, you fix it.
You fix it everywhere.
Would be is in the case where you're storing JSON inside the table, if it's fairly large, won't they get contention? Would they end up resorting? Well, I guess you said they might normalize it to get.
Yeah, these are all valid. So he's saying, wouldn't you get contention if you made this JSON too big? That's valid, absolutely valid, right? Maybe we will, maybe we won't, we don't know, but we can change it when we need to. We can, look, just to make this go full circle, how many of you have empty tables in your database? Tables with no data in it. Why? Delete it. Why don't you delete it?
Third-party application.
Yeah, right. You don't know. Right. You don't know what you're going to break, right? OK. So my point isn't that you have to denormalize or normalize. My point is, if you design for reads, you will find cases where denormalization will greatly improve the reads. That's my point. Greatly improve it. OK?
How do you deal with the artifacts of the bug where, say, you don't populate total price, but you're free to fix that bug, but you can't do a data patch? How do you deal with the artifacts of the bug?
Well, that's another principle that maybe is a different class, but that's a DevOps class. But basically, we don't believe in database rollbacks. At my organization, we don't roll back. We only roll forward. So that means that if we have bugs, we wrap it in test, we create what we believe will solve that bug, and we push it only through the development pipeline. The reason why we disagree with production changes is because we are avoiding our deployment process. And if we have decided that it's effective to deploy the deployment process, that is actually a severe state to be in. That means that all the tests and all the safety nets and all the things that we have for deployment, for whatever reason, we have decided to bypass that, we have to ask ourselves a very serious question why we would ever do that, right? No, we don't leave the data broken. The fix goes through the deployment pipeline.
But it's still a data fix, right?
Yeah, it's still a data fix.
Data statement, whether it's
It's testable, right? And so it's not somebody with SSMS running an update, which is what everybody else thinks when they think about data fix in production. They think somebody's connecting using a tool, and they're in production fixing data. That's
another step in your process.
oh yeah, oh great. If you think that, that's great, right? But that's again possible because we have an application deployment process that is testable and repeatable. And another thing that's helpful for that is one application, one database, because we've reduced the testing surface area, right? So that kind of thing becomes possible because the surface area is reduced, and that means the test can run quickly and get done quickly, okay? Yeah.
So the way you have it outlined, like the customer table, if that's maintained entirely by the application,
Yeah,
and multiple screens in that application might be touching that customer table,
absolutely.
then you could end up with duplication of business logic, which is problematic if it's not maintained properly.
No, that isn't true. That isn't true. No, that isn't true. Because we consolidate the data access and the business logic in one place, and we wrap it in tests. So for instance, if I want to check if a user's logged in, I don't need to go to a database every single time and ask select star where user is logged in or right. What? I just create a function that says check if the user's logged in. Now I've obeyed the don't repeat yourself principle. I have the single responsibility principle, right? And then we wrap that thing in tests, and we can always tell if a user's logged in or not, right?
But if I'm looking to see if a customer has an order, for
Yeah.
example, or if I have a page that is the customer's order,
Yep.
or if I have the page that is the sales manager's view on the customer's order, I might be touching it in 3 different screens.
Totally fine.
And if the logic belongs to any one of those could delete that order,
Yep, that's true.
then I would have to rewrite that total order amount and all of
No, you wouldn't.
based on.
No, you wouldn't. No, you wouldn't. No, you wouldn't. So the delete would only be in one place, and it would be wrapped in tests. You wouldn't have the logic in your head. You're thinking the code is in the screen, and in an application, it's not. No developer actually puts code in a screen. They consolidate it in the business logic layer. And if somebody ever says we have 16 procedures that delete a record from the customers table, like nobody would ever approve that pull request, right? Because they wouldn't want the duplication and they wouldn't want to maintain it, right?
So when you say application, you're looking at the data layer of the application having discrete actions that might be called by multiple screens.
Right. Yep. OK. But thank you for your feedback, by the way. All right, I want to keep going, but I promise we'll get back to you. Now, because I'm still provoking. I'm not done provoking. So what's wrong with 3 tables? Customers, order, and customer open orders. Is that scary? Yeah. So that's scary, Lewis. But I don't mean to pick on you. But what happens if I just create a view with customers and orders and I materialize the view? Is that scary if I put an index on a view? No. So Lewis is just comfortable with the engine enforcing data integrity. He's not comfortable with the application enforcing it. But yeah, right. And really uncomfortable with the duplication, right? But again, let's just pretend as a mental exercise, if I created a hybrid table, right, and I had to write an order, would I have to write to 2 different tables? Would I? Yeah, I would, right? But if I had to read a customer and all their open orders, could I read that pretty quickly? And reads outnumber writes 10 to 1. So when I say design schema for the reading, these are the kind of things I'm talking about, right? And again, you could argue, Lewis could be on our team. If he's on our team and we're all talking about, whatever, we're talking about our sales calculator, right? And he says, I don't like that design because I think it's going to have these bugs. That's fair feedback. But if we notice that we have bad reads and that we're joining too much to get the reads we want, we can absolutely implement something like this to correct that bug, right? We can. That is an option to us. We can do it. And we can do it successfully. Okay. Now, just so, while I end the provoking here right at this phase, before I get back into it, just so you know, the NoSQL developers are doing this all day, every day. This is how all NoSQL databases are modeled. It's the relational developers that are reluctant to do this. But the NoSQL developers do it in every single application they create. They do it all over the place. So what we're finding, just so you know I'm not making this up, is we're finding more and more relational developers who are valuing consistency over scale, implement NoSQL themes into their databases like this. So we are seeing this adopted in a wider industry. And if I'm being very frank with you, it's the Microsoft developers that are a little late to this. The Postgres developers have been doing this for 8 years. So we're a little bit on the late side. Okay? Yeah? Yeah, this is a NoSQL approach. Yep. Yep, yep.
So if you're in a transactional system, are you going to lean more for consistency at the expense of availability or partition tolerance?
Yeah, well, that's why we chose the relational store, is that we knew we were going to lean closer to consistency and availability, and we were going to lose partition tolerance, right? So we chose the RDBMS because we wanted to play on that side of the CAP theorem, right? So that's a pretty severe question for the wider audience, but I appreciate it. Yeah. Any other questions? Yeah.
So, since the design, do you suggest like constraint foreign key in this design or not?
Yeah, that's an interesting question, and that answer is, okay, yeah, pardon me. The question is, do you recommend using foreign keys? And in our applications, we tend to heavily rely on foreign keys. And the reason why is because it actually makes the optimizer make better decisions in the joining. So we like the performance that we get from foreign keys, right? But it's totally OK for the application to enforce the data integrity of its own data store in whatever way it wants to do it. Yep. OK. All right. So CDP number 4. We can come back to this. I just want to keep going, and then we'll come back. So make the schema easy and discoverable. So if I'm a new developer on a system, we would want to avoid having 300 different tables, because that is a schema that is not easy and it's not discoverable. And when we look at schemas that tend to explode in size, we often see columns that nobody is using, tables nobody is using, a bunch of acronyms nobody remembers the original acronym for, a bunch of jargon, a lot of spaces, and just a lot of stuff in there that is making it very noisy and difficult. So we want a schema that emphasizes simplicity over EF cod. So we want new developers to be able to be onboarded with a schema that they can get up to speed as quickly as they possibly can. Okay? CDP number 5, yeah.
It's interesting because a lot of the DevOps things I'm seeing people say is don't break backwards compatibility in their DevOps kind of stuff. But I guess you're doing the micro.
So in microservices, if we, that is not true where they say don't break backward compatibility. What they're actually saying in their API definitions is they're saying decide how many versions of the API you're going to support, and then stick to it. We support 3 in most of our applications, which means other developers, Phil's team, hey Phil, we're making some changes to the API, and now that's 1, right? If you hear me say 2 and 3, you better be off that 3rd version, because that means it's coming out, right? So that's a polite way of doing it. They need a change on their side. It is impolite for me to stand over Phil and say, Phil, you drink too much, and you stay up too late, and you actually, sometimes you stand too close to me, right? Like, that would be rude, right? Because I'm forcing Phil to change at my request, right? Something about me wants him to change. And so when we adopt changing APIs and microservices politely like that, we're basically saying, hey, Phil, on our side, change is coming. We don't want to tell you what to do, but you might want to wake up because change is coming here, okay? At your convenience, change with us, please, right? Okay. So CDP number 5, and this is provoking, but it is the network, not the disk, that is the real problem. Thank you. Thank you. So, no, I really mean it. Thank you. No, thanks. So in the cloud, you pay for 4 resources: compute, memory, disk, and network, right? Compute and memory, and in some areas, disk, is a slider bar. We slide it up and down. You ever see a slider bar for network? No. And network is a shared resource, definitely a shared resource. In the cloud, we can buy our own bare metal if we wanted, right? We can isolate ourselves in the cloud as much as we want, except the network never isolates, right? So when you hear application developers talking right now, and they say, hey, how's your app running right now? Do you know what application developers say today? They're like, not bad, 30 milliseconds. Oh, pretty damn good, 18 milliseconds right now, right? They don't say, oh, I wrote 1 million lines of code, or I did this, or I've got 50 gigs of data. The first words out of their mouth are involving latency. Great cloud developers are hyper concerned with latency. And they do all kinds of things to make the network not a factor in their application. All kinds of things. And we need to be looking at schema to design it so that the schema is very aware of the network, which means we should be minimizing round trips, only getting the columns and rows that we need, keeping our transactions small, and it is OK to say no to users. So I had a company, when you right-clicked in a grid in their application, it made 700 round trips to the database. And because, why does it do that? Well, the users said that if I'm Ike and I make a right-click, sometimes I want to create a note. But Larry, when he does a right-click, or Sarah, when she does a right-click, they want to tally up the total for that customer. And I was like, well, why did you say yes to that? Like, that doesn't sound right. So you have the application be completely different depending on the user? Yeah, but the users asked for it, right? And I said, wow, you probably should have said no. Because what are the users saying now? They're saying the application is too slow, unusable, they can't do anything with it, they hate it, and they're angry, right? I said, well, you were going to say no one day. You should have just said no a little earlier than you did say it, right? Right? So it's OK to say no. So in the case where somebody said earlier today, what happens if one screen has customers like this and one screen has customers like that? And what that's creating is a bunch of denormalized JSON in our data stores? Well, that might have been a result of just saying yes too much, right? So it's what we want to have is a relationship with the business where they understand what they're asking us. Because they often will ask us for things and they just don't understand the repercussions of it, right? And so what we want to be able to say is, yes, we will change with you, but that doesn't necessarily mean I give a 16-year-old a Ferrari, right? I mean, there's just some things that maybe we just have to say no to, right? And we're definitely not going to have 700 round trips on a grid when we right-click on it. We're just not going to do that because we design our application with the network involved. And we think about the network all the time. We think about that network from the time we wake up to the time we go to bed. It's a shared resource. It's hard to upgrade. And we're worried about latency. And we think about it definitely when we design schema. So if we're designing for the network, doesn't that make like the customer open orders maybe make a little more sense? Because I can just get the columns that I want. I can get the rows that I want. I can compress if it's a lot. I can keep my I/O path small. And maybe I am modeling that for the screen, right? So now the UI and the use case for the data is informing the data model instead of the other way around. And what we've had in over-normalized databases too often is the data model has been informing the screen. And what we want is the user and the use case to inform the data model, right? The other direction, okay? All right. So we also optimize for the network for a lot of reasons. One is that if we were designing Tinder, where we swipe, 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 right? The users now are getting smarter on us. And the Tinder user knows that swiping should be fast, but writing should be slow. So when a Tinder user makes an update to their profile and they click save, they have the reasonable expectation that not everybody in the world is going to see those changes immediately. So they're getting used to this. Before, in the 80s, they weren't used to it. They wanted writes like that. But today, it is perfectly acceptable in an application to say, I know you want to make a write, and I will get to it when I get to it, right? Perfectly acceptable. They are used to that design notion. They are not used to when they swipe, having it lag on them. They get angry, and they report frustration when that happens. So when I say we design for the network and we design for reads, I'm doing it because the users are demanding it. They have the reasonable expectation that reads are fast and writes are slow. So another reason why we do it is if an application takes too long to load and too many round trips, we get affected by Google. Google thinks that we're not creating good applications, and they ding us for it. They do. And then you will go down in rankings. It is a very popular reason why you lose organic search results in Google, is because your load times are too slow. They want the reads to be fast, okay? So one of the ways that we make reads fast is we worry about data locality. We distribute our data around the world. This is a Cosmos screen, but it's fastly becoming an Azure SQL database screen. So you're going to begin seeing relational data products like Hyperscale optimize for reads and then distribute those reads around the world. You will see that. So you are seeing products behave the way application developers behave, which is optimize for reads first and foremost. Worry about the reads. That's where the performance problem is. Okay? All right. CDP number 6, think about the raw performance. Think of denormalization as just another index that your app is maintaining. So proper schema can increase performance by 1,000 times. I'm not exaggerating, 1,000 times. Limit joining and think about the indexing. What's the index signature? That's our priority. CDP number 7, what can we remove that isn't 100% necessary? Remember, in the cloud, specifically in cloud relational database design, we get dinged if we store cold, raw data that nobody uses. So what cold, raw data that nobody uses is existing in our database, even in our sales calculator, even in our little app that we're doing? What can we remove from that database and get out of our schema? Blobs, temp tables, staging data, all of that stuff can go to a different database or Azure Blob Storage or somewhere else that can be managed and scaled separately. Now, you might think, you're telling me, Ike, you said staging data can go to a different SQL database. Why would you do that? Because if I put staging data in a different database, I can make that thing have 2 vCores and pay a little, where my sales calculator has 20 vCores and pay a lot. So if I think about terms of scaling separately, I will create better schema and better modeling. Think about what you want to scale separately, okay? All right. CDP number 8, plan for partitioning. So the data may be partitioned, but even if it is never partitioned, even if you never end up partitioning it, thinking about it is a great exercise. Because what you'll think about in your application is, what data is likely to be used together, and I should keep that together. So if you know that customers and orders for the Northwest region are likely to be together, then OK, You ready to get provoked? It is OK to put Northwest region in both the customer and the orders table. That's data duplication. That's scary for a traditional relational developer. But what we're doing is we're doing a very popular thing called threading the partition key. We're taking the partition key and we're putting it in the tables that are likely to get access together. So that maybe one day, if we do need partitioning, we can rip all that out and put the Northwest data on its own server. Because why? Because we're optimizing for reads. That's why, right? OK. So partition keys are a very popular reason why we duplicate data, because we tend to put that partition key in every table that's likely to be accessed together. Even if it has no real relationship, we do that. They do it in Cosmos. They do it in Mongo all day long, right? OK. All right, you guys heard of CQRS? That's a very popular way to design applications right now. People love it. Your application developers are reading about it right now, OK? But let's just say that even without CQRS, let's just say that this is a very typical way that an application does work now. And this is what we would call a cloud scale application, which means that it could basically handle any load. 1 million users or 1 billion users, it could probably handle the load, OK? So an app takes your order. And immediately, what does the app do? It takes that order and it puts it on an event hub or a queue or a Kafka message queue. What's that? Kafka topic. Kafka topic, thank you. Yeah, thank you, topic, thank you. I'm used to event hub, right. So a Kafka topic, it does it immediately, right? And then it immediately responds to the user. Once the message software has acknowledged that it has received it, the app says, we have received your request. Like, we have taken your order. We have your Tinder profile update. We have confirmed that you want to make an order with us, and we will respond accordingly, right? How many of you have seen that in applications you're using right now? Amazon, Facebook, right? Over and over again, you're seeing that design. And now the users are prepared for a design like that. So then maybe an Azure function or some piece of code is responsible for listening to Kafka or listening to Service Bus, and it pulls that message off, and it says, OK, now that I have that message, I'm going to persist it to the data store. And maybe what that function does is it says, I know this user is going to want to read this message immediately, so I'm going to take it and put it in the store and put it in the Redis cache, because that's where I want them to read it out of cache. So I get the reads out of the data store. Now, I'm going to ask you something. The minute we use the Redis cache, aren't we just duplicating the data? And if the cache is out of date, isn't that just a bug for my sales calculator to fix, right? So now you see these design principles, how they're coming together, aren't they? If I already have agreed that caching is duplicating data, and that when caching is not tombstoned correctly or having a problem, that we have something we have to fix, now we can begin using data schema in a creative way to optimize for reads, right? Because now we're just arguing about the location of it, right? Not the implementation of it, right? OK. OK, so what time do we have? We got like 10, what? 10 minutes, OK. What questions do you have? I put you off, OK. So many, yeah. And then, by the way, I'm sorry, before the question, I know that you are thinking a million things right now. I know that. And I know that you're like, is this real? Like, is this something that I should be reacting to? Like, is he right? Maybe he's wrong, right? But again, let's say that I'm wrong, right? On the design principles, am I right that schema has to change? Am I right that we need to be designing for the network? Am I right that we need to be designing for reads? Right. And in application after application after application, I see the rights emphasized. And honestly, if we can get the reads out of the database with cache, we can get the writes out of the database with Kafka and Event Hub. So if we decouple both of them, which is the whole point of CQRS, we can scale both of them separately. And that's the point of schema this way, is that these things are getting scaled separately, right? OK, all right. So if you start thinking about it that way, you'll start thinking of your schema more creatively. And that's why I'm provoking you, is because I want the design principles to change, and then you get creative on the other side and worry about the network. OK, does that make sense? All right, your question, sorry.
So I'm kind of stuck in a hard place.
Yeah.
Because what you're talking about is changing the schema, and part of that is, naming conventions, like you showed in your example. They wanted to change the name from student to learner.
Yep.
And yet that was a business, and in your whatever it was,
CQRS, yeah.
number 4, I think.
Oh, CDP, yeah, number 4. Yeah, all right.
You had business something or other down on the bottom part of the slide, and business names.
Yeah.
So at one point in time, that schema name, they had determined that that name was going to be student.
Yes.
Now the schema is changing because they're now saying, no, we want the schema name of our thing to be students now, or learners now.
Right. So I'm not sure I understand the question.
So you're going to go in and change all your table names to learners now?
Yep.
Okay,
Yep, and why are we doing that?
because the business has changed.
Right, and now this is the important part. Are business users allowed on the database?
No.
So why do it if the business users can't see it? Yeah.
Well, because the business is okay, well, why did we go in and change everything from Power BI, blah, 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 to Power BI, blah, blah, this?
Right. So the reason why we do it, if the business users can't see it, is because when technology and business use different language, that is where bugs are created. So we're doing it to be in a line with the business so that we can change with them. And so that our thoughts change with them, our ideas change with them, and we change with them, and we embrace it. That's why. Yeah.
Can you just cut that down and say we do it because of turnover in the application?
Yeah, right. Do you want to be supporting taxonomy that's 30 years old? Like nobody knows why we named this shit, FKLMO or whatever, right?
Named it retired 4 years ago. Or
Yeah.
write anything down?
Right, right. OK, what's your question,
So,
Christopher?
thank you. A lot of this seems to be, and I really am hoping that you're going to correct me and that I'm wrong here.
No, go ahead.
A lot of what you brought up here today seems to be reinforcing the idea of the us versus them mentality between the data professional and the application developer and the network team and the business.
Well, no, because what I'm saying in the cloud,
They are,
yeah,
the worse your results are in the end.
right. Well, no, I'm not us versus them. I'm not. I'm definitely not. I am saying that there is no us or them in the cloud. That in the cloud, those two guys are teammates with one boss. And they have to interact and talk to each other and be together. Yeah. Oh, thank you, Will. Thanks. Yeah. Or the same person. Yeah, or the same person. Right. Okay.
I'm getting out of this is you're saying the traditional way of doing database design is no longer practical. Oh, please don't be saying
I know.
It's not true. I'm just saying it was for a different set of like for instance, you create 2 tables with the same schema that that normally would shock me right away. I said, how are you doing that? You're gonna have 2 foreign keys and stuff like that. But it's about practicality, right?
Yeah, right.
That's why you
I'm
wanna
saying that if you continue to create large monolithic applications that share one data store with 4 applications on it, you will inherently create something that cannot ever go to the cloud. And if you tell your organization you can't go to the cloud, you're going to be looking for a new job. And that's just a fact of life, you guys. Like, this is an inevitable issue right now. I promise you, I have 20 full-time employees. I deal business with companies that are in this room, that are very large companies. They pay my organization to teach them where they're headed, right? And I'm telling you, they're all moving to the cloud. And a lot of you are thinking, oh, they're doing that, but it's so expensive. They're doing that, but it's cost prohibitive. They're doing that for all the wrong reasons. But here's the reality. The money doesn't matter. They don't care about the money. They care about the opportunity cost of losing out on a technology that gets released to the cloud that they can't take advantage of. That's what they care about. They care that their competitors are going to take advantage of Azure ML services, and they're not going to get to it because it's cloud only. And increasingly, all the innovation in our environment is being done in AWS, GCP, Azure, and that's where it's going to continue to be. And the on-premise products are going to innovate and upgrade much, much slower at a slower rev. And so we can either embrace the change that's coming to us. We can embrace a mountain of technology change that is hurling toward us, or we can ignore it and get hit in the back of the head with it. But what we can't do is pretend it's not happening and make it go away. It's not going to go away, right? Okay.
This wasn't a good idea for
Oh, thank you.
It's not like this isn't a good idea for on-prem either.
Yeah, no.
Some of the stuff
All right, some of it he wants to complain about, yeah.
I mean, but the idea of not having 50 applications on one database, that still sucks on-prem.
Yeah.
No matter where you're at.
Yeah, okay. Can I just do one thing and then you can take questions to me one at a time? I hope you felt like I took your questions seriously and I'll stay here, but I have to catch a flight. So follow me on Twitter and tweet questions to me and I'll respond to you. I want you to know your questions are important to me. Like it's important that you work this mayhem out in your head so that you have calm about this. But just real quick, let's talk about blogging, okay? So if I traditionally had a comments table, right, and a post table, the post was for the post, then let's just be a little creative and say that when I load my blog screen, I have top 3 comments in that screen. And so I take those top 3 comments and I put it in the post table. So I might still have a comment table. That's still valuable. But maybe I take the top 3 that load that screen and I stuff it in the post table in a JSON column. And why would I do that? Would that be good for the network round trips? Yes. Would it be good for the reading? Would it be easier for the developer who's loading that screen to know where their data is? Yes, right? So you can see that I'm advocating that if we consider these things as design principles, we will create schema that is good for the cloud today and good for your applications tomorrow, and that you will be able to change that as your priorities and your team's needs change in the future. That's what I'm advocating. And I hope you get that out of this thing. And I really appreciate your time, and I'll let you go. Thank you very much. Thanks.